Thank you so much. I see everybody's getting their headphones on. I'm going to pass this off to our next speaker, Mickey, who's going to talk about how MongoDB can serve as a memory store for agents. Break a leg.
Thank you. Okay. Hey, everyone. So, we have a problem. We are facing a crisis in AI implementation. And I don't use that word lightly. How many people have seen this report? Raise your hands. I know we all have, especially if you have a LinkedIn profile. So MIT studied hundreds of enterprises this summer. And the finding was 95% of those GenAI initiatives are useless. $0 value. They do nothing, nada, zilch. They fail to deliver on long-term value. Only 5% succeeded. And this is what we call the GenAI divide. Now, the fun fact is the barrier wasn't infra, regulation, or talent. These findings were pretty similar whether you were in AMER, EMEA, APAC, whether you were in healthcare versus finance, versus something a little bit more loosey-goosey like a consumer application. And they didn't necessarily depend on, for example, whether you had a unicorn AI engineer or an AI engineering team. Now, what is the problem that makes it so that a $20 consumer app, or $200, depending on what plan you are, beats out a $50,000, $20,000 enterprise implementation? Now, there are two fundamental limitations that LLM-based agentic systems run into: static weights and a short context window. Now, some of you may be encouraged to ask me, well, but Mickey, we have a 1 million token context window LLMs now. Surely that's big enough. I mean, that gets you at least a 50-page essay in college. That gets you reading multiple research papers. Now, the fun fact is we're now in that stage where we have labs, we have research teams, we have builders and enterprise contexts that are now producing blog posts, papers, you name it. And a bunch of them are basically saying the same thing, which is that a 1 million token context window LLM, just because you use it, does not, in fact, guarantee reliable performance or effective performance with a 1 million token context window task. So my name is Mickey, Mikiko Chandrasekhar. You might have seen on the schedule that my last name is Baisley. I am still adjusting to my new last name. I got married in April. Today, we're going to turn stateless LLM apps into intelligent agents with memory. I should also mention I'm a AI/ML developer advocate at Mongo. So there are 3 takeaways that, if I do my job right, you'll think about after the session is over. They'll hopefully impact how you think about MongoDB, and especially how we're tackling AI. The first one is MongoDB as a memory provider for AI agents, not just as a database, but also providing the foundations for the cognitive architectures you would build. The second is with Voyage AI, we bring intelligence directly to the data layer. So these embeddings become the atomic unit of these RAG-based systems. Dev has talked about this in the keynote, lots of people have, but beyond prompt or context engineering, which is a term that has also started coming about, memory engineering design systems track exploration paths, maintain state, and learn over time. This is what agentic systems require, in addition to the operational and search capabilities that MongoDB has traditionally provided. So, how we got here and what's changed. Now, first, who here has built an LLM-powered chatbot? Raise your hands. Excellent. Who here has built a chatbot with RAG? Excellent. Good. Who's building AI agents? Who's building it in production and not side questing it? Ah, ha, 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 ha. Good. That's okay. That's okay. There's nothing wrong with that. And who here is building or is looking at building an agentic system? Actually, who knows what that even means? Excellent. Good, good. Okay. So AI form factors have evolved pretty drastically within the last 4 years. Seems like only a couple years ago, I was on the MLOps team over at MailChimp. And we deal with a lot of text data there, emails, duh. GPT-4 had not come out yet. But we'd gotten early access to see like how could we essentially start building those capabilities into the newsletter, email marketing features that we offered. And since then, we've kind of just had an explosion of so many different types of commoditization all along the AI stack, which is awesome. But what we're also seeing, though, is simple RAG doesn't cut it. Single query, single retrieval, that's not the final stop. Who here has had the experience where you're having a long multi-turn conversation with a chatbot? Maybe you're using it to build out a knowledge base. Maybe you're using it to help the marketing team generate copy. You use it, and then it just stops. It flatlines at a certain point. Who here has used something like that and gone like, when did it start sucking? Like, really? Yeah, all of us. Especially with, like, I don't want to name names, but there's a certain platform that at a certain point they'll say, like, oh, we run out of memory, and then they'll boot you. And then you have to generate a summary, go to the next chat, and go like, well, the agent before you, now help me finish this. And then you do that like 4 or 5 times over. I did that like 8 times for this talk. No, I'm kidding. So simple RAG, it's good, but it's not enough. Especially, for example, with copilots that are building large code base agents. What they're seeing is modern agentic RAG, where you let the agent decide when and how to search. That's where you get really kind of the best experience. And that requires memory. I'm going to use that word a lot. And once again, there's a ton of research that backs it up. They back up the fact that models get lost in the middle in long context. DeepMind recently came out with a paper that I thought was quite excellent. And what they showed was that single vector embeddings have ceilings. When queries mix concepts, recall collapses. I would highly recommend reading this paper. They even have a formula that's like, it's a cubic function of like the dimensions of the embedding model. And essentially at that point, it's like, brr, performance just sinks. But that's not to say that search, RAG, etc. isn't valuable. It is. But we have to figure out how do we combine all these different modes of data retrieval to provide intelligent information to our LLMs, our agents. More than likely, any agents people build are going to be overwhelmingly LLM-based, but they are now multimodal models, for which this will also be a problem. It's not like it's solved, right? So first, let's just recap on RAG. I'm not going to give you the full 101. Also, we have a ton of resources, if you need it, that will do so. But I'm going to give you the high points. OK, so what is RAG? I'm not reading out the definition here. But what I'm going to do is just summarize it as RAG brings external data into context. It does so based off of some similarity mechanism. And the idea is, so you don't distract your LLM. You only show the right information that is relevant to the user's query. Now, there are so many different methods for different jobs when it comes to bringing data to your LLM. The simplest one is just text retrieval. Like, you can think of it for keywords and filters like you would use in a MongoDB query. And And this basically does some kind of exact or partial match. And then you get results. The second way you can start bringing data into your LLM, to your context window, is through the use of embedding models. Now, embedding models essentially take very complex unstructured information, they collapse it down into a unit that can, in fact, be used in a calculation. And they also help capture meaning beyond keywords. Embedding models are used in vector search to surface up the right information based on this semantic meaning. Now, actually, let's just go back here. This is an incredibly powerful method of retrieval. Some would argue it's more powerful than full and partial text matching. But you do have a problem in that each of these will cover a certain subset of results. They're still going to miss stuff in between. Let's say, for example, your user is searching for restaurant recommendations within Midtown. That's great, except then it points you to a different Midtown, not in the New York area. I guarantee you there are many Midtowns in the world. There's not just one. Let's say, for example, a person also wants healthy food. And great, it shows you all the results that's close to them, but not in the place that they're going to be traveling. So hybrid search is a combination of full text search and semantic search. And the idea is that when you combine these two, you get better precision recall. So user query, give me healthy restaurants in New York. Full text goes, OK, let me just find you all the restaurants that are in New York. And then let me then go find all the restaurants that had some reviews associated with them that said oh, this was an incredibly delightful meal. I didn't feel at all bloated. I kept to my promises to eat a healthier set of greens. You get these results from the two queries, and then you combine them together, which are then re-ranked such that you're providing the most relevant information to the LLM, but not too much information. That's the key. Right? Remember, large context, performance sinks. And this is what that RAG pipeline will look like, right? Now, retrieval is great. It's still not learning. Let's think back to what that paper said, right? Which is about learning, adaptability. These are common issues that people very much so dislike about the user experience with agents that don't have memory. OK, now, what actually makes something an agent? Long definition. You can think of it in terms of kind of 4 faculties. The first one is cognition, or reasoning, which is provided by an LLM. My bad, sorry. That was a preview. LLMs need, or agents, backed by an LLM, they need to take actions. If you're essentially just copy-pasting stuff in between different applications, so for example, you're trying to book travel, that's not really super helpful. I mean, that's kind of basically what we do nowadays. So you need these agents to take action. The third part is perception in the form of inputs. And finally, memory, short and long term. Memory is the thing that persists across sessions, and that's why we put it up to the top. So just a basic example, right? Now, in terms of tools, you can have many, many different tools. Fun, and the fun sort of part about how RAG and memory react together is RAG can be a form of a tool, right? Now, general recommendation we do have is you probably shouldn't be exposing more than 5 to 8 tools to your agent. Fun fact, okay, actually question time. What do you think is the average number of tool calls an enterprise agent performs on a complex task? Now I'm going to ask you, raise your hands. Do you think it is less than 20? Okay. How about 20 to 30? 30 to 40? 40 to 50? Okay, yeah. Some people have been reading. Specifically, they've been reading the Manus AI blog post, the one that says that their coding copilot took 50 tool calls. 50 tool calls to complete a complex action. I worked with a company called SourceGraph at my previous gig at Fireworks, and we found that, yeah, essentially, like, if you are dealing with a large code base, you can definitely guarantee it's making 50 tool calls of some kind, right? Now, the fun fact also is all those tool calls, all the metadata starts polluting your context window, and that is why if you have a 1 million context window LM, you're maybe only using about 20% of it effectively. The rest of it is just metadata and all this other nonsense that pollutes it. Also, all the times where you're like, yo, you did this wrong. Fix this thing. Now, this is roughly what your agents will look like if you're dealing with a single agent system. We talked about tools, planning, perception, and we also have memory. Who is familiar with all the different forms of memory here? Excellent. You will get mad value for the buck in the next, hopefully, 10 minutes. So with memory, preferences and constraints carry forward automatically. Well, not automatically. I mean, as a developer, you have to set it up. But from the user's perspective, it feels automatic. It feels magical. But ultimately, this is the difference between like an agent with autonomy and RPA. This is a huge, huge part of that delta in developer experience, in user experience, not developer. Once again, let's come back to this, right? What they found was that the issue was not how good the LLM you were using, regardless of whether it's the most recent like reasoning model or what have you. It's not the raw IQ of the LLMs, and it's not the raw IQ of the coders that are building these things, like myself. It's memory that enables what they call RBC, which sounds like Arby's. Delicious. Reliability, believability, capability. That is what separates the 5% from the 90% of generative AI initiatives that fail. They didn't say those initiatives failed because they didn't work. They failed because there was low adoption, people weren't engaged, and eventually they would just go do their own shadow LLM ops or shadow GenAI initiatives. Once again, going back to, this is a fantastic paper to read. Something like, in other papers like McKinsey and all that have talked about this, think enterprise AI initiatives. 25% of them are adopted, but 85% of employees are using them. What's going on with that number? Agent memory. So actually, I've been talking about it. Let's actually define it. So agent memory is the persistent system that lets agents learn, adapt, and maintain continuity across sessions. You can think of it as the LLM's ecocortex. This term will be relevant in a few slides, so keep in mind. Now, as I mentioned, how RAG fits into agent memory. Just to be clear, just because I said single query, single retrieval isn't useful doesn't mean I was like kicking RAG to the door. That is incorrect. We love RAG. Why? Because RAG fits into the agent memory as one of the core mechanisms agents use to extend what they know beyond their parametric LLM weights. RAG is the retrieval layer. Agent memory is the broader system. Now, memory isn't one size fits all. Different operations need different memory types. I'll kind of go over these briefly, but I'll also kind of point you to a blog post after this that you should check out for more deets. Now let's zoom in on short-term memory. It's the one in blue. We think of it as the now layer. Fast, session scoped, cheap. It stabilizes multi-turn context, so you're not thrashing the LLM. There's two types, working memory and semantic. You can think of working memory as the active subset of short-term memory. It's a scratch pad, holding the current turns, tool outputs, and interim nodes. You summarize or drop it when it's no longer useful. Semantic cache is the other type of short-term memory. And you can think of this as like the cost mechanism, cost and latency. If a new query is semantically close, you reuse that response and you don't generate additional LM calls. This becomes important when you're dealing with multi-agent systems for which they can become very expensive. Cache hits can turn 800 to 1500 millisecond responses into 10, 50 milliseconds. With moderate hit rates, teams often see a 30 to 40% LM cost reductions and a smoother user experience. Now, this isn't really like the learning part of the memory. This is just what keeps the agent steady across turns. Now, let's zoom in on the other type of memory, long term. So these are the memories that persist. A couple different types. We have episodic memory. We can think of it as autobiographical history. You keep the raw turns, the rolling summaries. Summaries can be triggered by token budget, time, or importance. The idea is that the agent recalls the gist without dragging the full transcripts. Semantic memory, not the same as semantic cache, semantic memory. So this stores things like facts, entities, and personas. Very important for personas for multi-agent systems. The idea is that you can apply freshness windows and conflict resolution such that new evidence weakens or just kicks for old memory. And once again, persona memory is that of like the profile. So instead of constantly saying like, oh, you are a helpful marketing assistant, or you are a stern but supportive professor, you have that stored someplace else, so you're not constantly just like rewriting and manually refeeding the system prompt. It's my favorite type of memory. Another part of that long-term memory is workflow memory. So this is what we're seeing when, for example, so one of our partners, N8N, they allow both technical and non-technical users to build GenAI or agentic workflows. So this is the kind of memory that they look at implementing. Workflow memory logs every tool call as a step, arguments, results, timestamps, errors, and it creates a replayable trace to resume or roll back. This trail lets agents resume at step 8 of 10 and improve the next run. And finally, we have shared memory. This is my favorite type of memory. Why? Because once again, multi-agent systems. Actually, who here is building a multi-agent system? It's fine if it's side questing. OK, awesome. Very, very good. Now, some papers that have come out recently, some of the findings that, to me, are incredibly interesting is, for example, Carnegie Mellon had done an experiment with Agent Company, I think was what it was called. And basically what they found was that if agents were not exposed to some kind of grounding, they would basically like lie and deceit, and they basically couldn't even do things like click buttons. So if your job or the job of your users requires like clicking buttons on pop-up windows, like you're good for now, right? But for multi-agent systems, you still need those other kinds of memory, but you also need shared memory. Who here uses the deep research mode of Claude? Lies, many of you do. I know you do. I do it all the time. It's OK. I personally love using the Claude deep research memory. And I even loved more reading the blog post. Using it's cool. Blog post is better. One of the things that they did point out was that if your agents didn't have like a strong sense of self, if they didn't have like memory to like help them remember what they were actually supposed to be working on, they would kind of just explode. So they had to essentially build a lot of guardrails, build a lot of evaluations to make sure that that didn't happen. Shared memory is the collaboration space of all the memory types. There's a couple different ways you can kind of shake it. You could either do append-only logs, so that, for example, if you have agents that are working on a complex task together, they can kind of post partial solutions and then eventually kind of work their way to an actual answer. You can formulate it more as like a short-term thing for intense goals, or you could do long-lived ones for like learnings for you as the team. And what's important is that if you're using a database that supports agent memory, ACID concerns. So these things prevent race conditions of your agents, right? Super, super important. So it's not like the database stuff doesn't matter, it does. Okay, so there are 3 different ways. Here's a MongoDB spiel. Okay, so there are 3 different ways that you can use MongoDB as a memory store for your agentic systems. First one is through integrations that you already use. The second is through open source patterns that you can adopt and extend. And the third, this is something special that I'm just going to not quite preview, but kind of give you a sneak peek on, is EXO memory. It's going to be our framework for production memory for the enterprise. Right, so first one, integrations. If you're already building stuff with our partners, Agno, Mastra, MCP, LangGraph, LangMem, Llama Index, CrewAI, Mem0, then you're in a good spot. Because essentially you can just plug and play MongoDB into these orchestration frameworks. Now, special call out for a very, very recent launch is Vercel v0. It did not make the slides, but is incredibly important because like agentic builders and AI engineers, they're not just like from the traditional data and ML background like myself. A lot of them are like front and back end developers. So our partners are really kind of helping to bring the best of all the research that's been going on and to help democratize access to a lot of these GenAI integrations. So big shout out to Vercel. Option 2, let's say you want more control via custom solutions. You have a team of advanced developers, and you just kind of want to see what these memory patterns could look like, and you want to implement it yourself outside of any kind of orchestration framework. So we can do that. So we have key experts from MongoDB in our community have been developing these patterns in public through a project called Memoriz. I didn't come up with that name. The guy who did is Gen Z. Love him though, he's great. So once again, like a lot of these memory patterns I've already talked about, they are available. You can go take a look at them here. You can scan to get the code, notebooks, and sample data. PRs are very welcome. So they are rough edges, but once again, we're building these patterns in the open with the community. So just let us know through a PR, right? And here's the thing, like we are constantly, like this is a very fast moving space. We don't know everything, but what we are trying to do is we're trying to keep in touch with the community. We're trying to see what do customers and users need, and we're trying to build that back into MongoDB. And we're taking those learnings from our illustrious history of being there for your operational data, for your vector store needs. And we're building it into this thing called EXO memory. Now, once again, this is just like a teaser. They're still building this. They're still getting feedback from customers. So this will be the framework for production memory with MongoDB. It isn't shipped yet, but here are some kind of key points of what we're trying to do. So the goal is to build an opinionated batteries included system that unifies short-term, long-term, and shared memory, that adds workflow logging, and also provides hybrid retrieval patterns. So we're building it with real customer patterns, and we'll definitely share updates as it matures. So whichever path you choose, integrations, open source, EXO memory, MongoDB is hopefully the memory provider underneath, providing text, vector, graph retrieval in one place, where with ACID, where correctness matters. Now, how Voyage tightens the loop. So my colleagues, Frank and Apurva, mentioned it earlier today in the keynote. So with Voyage embeddings and re-rankers integrated, the idea is that you bring the data, Atlas returns memory-ready components. The idea is to move intelligence into the data layer for domains like law, finance, code. And we do that by ensuring that we don't just shove any random data into an LLM, or even just data that oh, it looks similar, but to really provide high quality information to your LLMs, knowing that context windows are limited. So, just to summarize, you can think of memory types as patterns you compose, like ingredients for a recipe. These memories work because retrieval is hybrid. The way to think about these patterns is short-term memory is steady answers now, working cache. Long-term memory is durable knowledge. And shared memory is for safe collaboration. So these are the ingredients. The recipe does depend on your application mode. Why is that important? Well, it's because architecture follows application mode. So the idea is that you want to pick the mode first, then choose the blend of memory types and retrieval patterns that support that mode. The three modes that we're seeing most commonly right now are assistants, workflows, and deep research style agents. I'm sorry, guys, but you should get access to the slides. You should. I think they'll have a playback of this, so feel free to check it out. Also, we do have blog posts that we've published. So check out the developers' blog posts for bringing attention to memory. Now, just to reiterate, what happens when you don't have some kind of memory for your agentic systems? First off, you have hallucinations. Now, remember the times or the days where people are like, oh yeah, the way you prevent hallucinations is by setting the temp parameter to 0. Unfortunately, people still say that, so it's not like it's in the past. But the best way to prevent hallucination is to ground it in real information, real knowledge, because essentially that's what happens. Models are stale. You give them a complex task, and if they don't have the tools or all that good stuff, they're just going to lie and pretend that they understood what you were saying. There are so many different types of failures. A paper that I really enjoy referencing is one called Why LLM-Based Agents Fail. And what was really cool is that they had created this taxonomy called the MAST, which is multi-agent system taxonomy failures or whatever. And what they had actually done was they had done multiple runs of multi-agent system kind of tasks, and then they had attempted to identify here are the different types of failures, and here's roughly the proportion for which they'll occur. I would highly recommend looking up that paper, because essentially all these things sort of happen. Now, the thing that I'm bullish on that people realize is that when people think of multi-agent systems, they all think coordination. And what I would posit actually is that coordination failures are still coming back to these systems. These agents in a system don't know who they are. They forget what they're working on. And they need a place to essentially dump those interim steps of a problem. Okay, we're at the end, folks. So here's the thing. I opened up with a promise. I kind of showed you how you could take these stateless LLM maps into intelligent agents with memory. How do you become that 5% that actually succeeds? And here's the steps that you go about it. So the first one is you pick your use case, and you understand what application mode are you working in? Is it an assistant? Is it a deep research agent? Is it a workflow? Then, based on that application mode, you figure out what's the right blend of memory types. So short-term memory to study answers and cut latency, long-term to accumulate knowledge, and shared in case you have multiple agents. And then next you figure out, how are you going to implement MongoDB as a memory store? Are you going to build it on your own? Are you going to operate through one of our known providers or known partners? Or are you going to come to us when we have exo memory ready? And finally, just remember that at the end of the day, a lot of people, whenever a new model comes out, there's this debate about, like RAG versus fine-tuning versus whatever. No, you need all of them. The simpler the user experience feels, the more complicated the actual code behind it is, right? And that's essentially like, if you're in a domain like medical, like legal, like finance, the data that you have absolutely matters. And if you do a good job investing in the curation and structuring of your data, guess what? You can use it for RAG. You can use it to fine-tune. We have a customer, Harvey AI. They essentially fine-tuned their own custom embedding models with Voyage because the off-the-rack stuff just wasn't working. Like the legal domain has very, very specific terms and definitions and meanings. They couldn't be okay with 80% right. So you need everything. You need RAG, you need fine-tuning. You don't just need a database to store your operational data. You don't just need a database for your vector store. And you don't just need a database for your agent memory. What you need is something that does all three. But most importantly is that you can build all this. This is not rocket science. I am definitely not the smartest tool in the shed. I would say I'm a pretty mid. I know you guys here are much smarter than me. You're much more capable. And what I know is that with this blueprint, you guys are going to become that 5%. I believe in you, team. Go Mets. Yes, New York. Yeah. Go New York teams. Yay. And that's it. So let me know if you have any questions. Hit me up after the session. I'll be around. Yeah. Sure.
All right, thank you so much, Mickey. Thank you, everybody, for listening in. We have a couple minutes now for Q&A. If you have any questions for Mickey, you can raise your hand, and we will run a microphone over to you.
I think I'm hearing the podcast.
You might be. Oh, yeah, you're on the wrong thing. Is the other one blue? Yeah, grab the blue one.
Oh, okay.
Any questions out there in the crowd?
Now I can hear you.
No questions? Oh, yeah, one in the back.
Ayo.
What do you think about even longer term memory for like observability and like logging and tracking, and then future retraining? So like short-term session memory, long-term context type memory, and then even longer tail data lake type storage, BigQuery type thing.
Yeah, absolutely. So the first question I can answer is eval and monitoring. So we actually, I think, announced also recently we have an integration with Galileo, and I know we're looking at more monitoring and observability companies. Evals is very, very top of mind, like for us, and I know for a lot of builders in the space. And I think this is where having these different memory patterns is really important, because once again, it comes back to like a lot of people will look at LLM and say like, oh, well, like the costs are pretty minimal per like LLM call, but they do add up over time, and they will add up over like very complex tasks. Most importantly, users, I know that when I interact with an agent, I'm not always providing like a perfectly written prompt, right? There's a certain amount of me trying to figure out and me trying to understand what is the end outcome I want when I work with an agent. And so I think the more you can do on the developer side to kind of learn from the interactions across all your users, the better and the more magical that experience will be. Now the second part is about like data for like retraining and fine-tuning, right? So something that I think is a really fun idea is, so there's an argument about how useful is vibe coding, right? Is it good, is it bad? Personally, I love the very inefficient but entertaining acronym. But here's the thing, right? Like each tool has its place. So something that I really like, not just when I'm like working with a co-pilot to help me like develop apps and so on, but also for all the other types of agents, is what they call spec-driven development. And I think that's where the long-term memory, but also the different types of retrieval can like play a huge part in that. Essentially, if you make it easy for people to provide what they are looking for through the interface, and you have all that data, all those traces, it becomes like super fast to essentially deliver them what they need. So that's kind of my particular thoughts on it. I mean, let me know if you have any follow-ups. Also, it's not just about like text retrieval or vector search. We do also offer the ability to do graph rag as well. And I think that when I've talked to people who work on like the data lakes or even like kind of in the graph data world, there's a lot of benefits to that as well, in that not all data, like data has some kind of relationships, right? And so if you're able to incorporate graph rag as one of the other kind of retrieval mechanisms, that drastically improves the quality of the response as well for the agent.
Any other questions? Okay, folks. Well, let's give a round of applause for Mickey. Thank you so much for a great session.
Thanks, everyone.
Thank you, Mickey.